Welcome, ladies and gentlemen, to your video lesson on adding and subtracting one-step equations. Let's do this. So there's a think about section right here, and I'm asking you to think about what you know about the equation x plus 5 is equal to 8. Is it easy for you to find the value of x? And then how could you explain this to someone who it is not obvious to? How would you explain how you know what the value of x is in this equation? Pause and think about it, and then be ready to rock and roll. So the main idea is that whatever you do to one side of an equation, you have to do to the other side so that the sides remain equal. If you think about an equal sign, it's like a balance. If you have siblings, you want your parents to spend the same amount on you as they spend on your siblings. If they don't, it's unequal. We want it to stay equal, so that's the goal when looking at equations. Last time you heard about words like inverse operations. That is what we use to help find the unknown variable in an equation. The inverse operation of addition is subtraction, and likewise the opposite of subtraction is addition. Division will undo multiplication, and multiplication will undo division. So here are some steps for solving one-step equations. This would be a good thing to pause and write down as you have them nearby, so then when you look at equations, you can follow step by steps. First thing you want to do is write the equation, so whatever it might show up to be. So again, I'll just go back to x plus 5 equals 8. Step 1, you might want to draw a slide or train tracks. What I do is just go right like that, keeping that equal sign by itself because the ultimate goal, again, is to remain equal. We want the sides to stay the same, so that's emphasizing that and helping you stay organized. Third step is to use the inverse operations to isolate the variable. Isolate the variable means to get the variable by itself. Inverse, again, is the opposite, undoing operation. So if I add 5 to x to get to 8, I can undo that by taking 5 away from x to get for what you had beforehand. So I undo. 5 minus 5 is 0, so I'm just left with x on this side. 8 minus 5 is 3. So then I have 3, and I'm going to then, so that's me solving for my variable. Most importantly, you need to check your solution to see that it's true. Remember, a solution is only a solution if it makes the sentence true. So I plug that x back in for where it goes. 3 plus 5 equals 8. And I check 3 plus 5 is 8. So since my sentence is true, my solution is correct. Those are your steps for one-step equations. So I'm going to try 3 one-step addition equations, then you'll try 3. So first thing I'm going to do for x plus 6 equals 4, I'm going to do my train tracks. The inverse of adding is subtraction, so I want to get x alone. I want to find out one single x is, so I take 6 away. 6 minus 6 is 0. I'm left with x. Here I have 4 minus 6. So notice integers, I'm going to add the opposite. I have more negatives than positives. 6 is 2 more than 4. Important to check my solution. Negative 2 plus 6 should equal 4. More positives than negatives. Since it works, my solution is correct. Train tracks. Inverse of adding 9 is subtracting 9. Y should equal 13. Check it. 13 plus 9 is equal to 22. I know that if I added 10, it'd be 23. 9 is 1 less than 10. So 22 does equal 22. My solution of 13 is correct. One more, notice that the variable's on the right now instead. That's okay. This is the same as g plus 6 is equal to negative 5. So if you'd rather rewrite it that way, so that your variable's first, that's fine. I'm going to leave it right now. Opposite of adding 6 is subtracting 6. From both sides, keep it equal. 6 minus 6 is 0. I'm left with one single g. Here I have a negative 5 minus 6. Add the opposite. I have a negative plus a negative. I'm getting more negative. 5 plus 6 is 11. So my answer right now is g equals negative 11. I'm going to plug it in to try it. Negative 5 should be negative 11 plus 6. Adding rules, more negatives than positives. 11 is 5 more than 6. Since it's true, my solution's correct, but I'm going to write it with my variable first. Here's 3 for you to try. Pause and come back. I will kind of whip through them with less commentary. So I'm going to do my train tracks. Inverse operation. So m should equal 11. Plug it back into check. Since it's true, my solution's correct. And obviously I'm showing you all the solutions are correct. If you plugged in, you got the wrong answer and you plugged it in, say I accidentally said this one was 10, then I would get 10 plus 4 equals 14, which is not equal to 15. That's how you know your solution was not correct. Okay, you're not going to see that from me very often because I'm trying to show you the right way. Again, train tracks. Notice h is second. This still means that you're adding. This is the same as writing h plus 5, since you can reverse addition. Same thing, so I'm still subtracting 5. So I have h is equal to a negative 12. Check it. 5 plus negative 12 should be negative 7. More negatives. And it's true. One more, train tracks. Inverse opposite of adding is subtracting. So I get f equals negative 7. Check it. Negative 3 is negative 7 plus 4. More negatives than positives. It's true, so my solution is f equals negative 7. Okay, last little few here, subtraction ones now. So if you see subtraction, you're going to do the inverse, which is adding. So make your tracks. Opposite of subtracting 2 is put that 2 back on. So I get x equals 3. Plug it in and check. 3 minus 2 should be 1. Sure enough. Train tracks. Inverse of subtract is add. Negative 3 plus 3 is 0. They're additive inverses. If you remember that word. Y equals 7. Plug it into check. 7 minus 3 is 4. Sure enough. Train tracks. Again, if you want to rearrange it so it's g minus 6 equals negative 8, that's fine. I'm going to add 6 back on, additive inverse. G is left alone, bring it down. Negative 8 plus 6, more negatives than positives. 8 is 2 more than 6. Plug it in. Negative 8 equals negative 2 minus 6. Add the opposite. Negative 8 is negative 8. So my solution of g equals negative 2 works out. Okay, very last 3. Pause here and try them. Write down questions as you have them. And we are nearly done. Train tracks. Inverse. Isolate variable for your solution. Check your solution using what you know about integers. And when your solution is correct, circle it. Train tracks. Inverse. Notice the steps stay the same. Check your solution. And rewrite your solution with your variable first. Last one, train tracks. Inverse. Check your solution. And hopefully you are not chasing me to solve this right now. Remember that you are just checking your solutions because you already paused to check to see if you know. That you never chase me, that you more, if you want to follow along and then rewrite later, follow your own pace of learning. That's what this is for. So last little bit, this slide here is for key concepts. Remembering your properties of equality so that if you subtract the same number from either side of an equation, the two sides remain equal. Just like if you add the same number to each side of the equation, they will stay equal. So some examples in numbers and some examples in algebra. All right, ladies and gentlemen, be your best self. Write down questions as you have them and come prepared to class. See you then.